Hello, friends. Part two of your podcast on Section 2.1 in the Algebra 2 book. Next thing up for us is the vertical line test. Okay, and when I'm looking at a graph, remember we had four different ways of representing relations. And I should mention that every function is a relation, but not every relation is a function. So part of what you're doing in this section is just determining which sets of ordered pairs, which graphs, which tables, which mapping diagrams are and are not functions. Okay, so the vertical line test is just what it sounds like. If I take a vertical line, say this vertical line, and I move it across a graph like this, if there's no point where my line hits more than one point on the graph, it is a function, as this one says it is. Now notice as I move across here, on this second example, I'm not hitting any points. When I get to the vertex right here, okay, just at one little lowest point, the one furthest to the left, I'm touching one point in the graph. But after I start moving past that, I am now hitting this graph in two different points. I'm hitting it right here, and I'm hitting it right here. As soon as the vertical line hits more than one point in the graph, it is no longer a function, it's a relation. So graphically, even if I had a set of points like I did back in the earlier example, okay, so here's a graph. Now this graph, think about this before I tell you the answer. Is this set of ordered pairs a function or not? Okay, think, and it's not. Now, it's not. What's the reason for that? I got 4 points on there. Which two make it not a function? And it's these two, because this x value, negative 2, has two y's associated with it. So I got negative 2, positive 2, and negative 2, negative 2. Here it is in the table. Okay, here they are in the ordered pairs, and here they are in the mapping diagram. So you need to be able to recognize in any of these situations when you're dealing with a function and when it's not a function. Okay, in these notes, they take you through another example on the graph with the points like I just did. One of these is a function, one of them is not. And if you read through, it gives you all that good stuff right here. And I have one here in a table and the graph. And when I plot the points, they are on a line. Okay, so this is sort of leading us into where we're going to go in the next section. All right, and now I finally get into actually solving some functions. So first thing I'm going to talk about is a function is just an equation written with this new notation. So instead of y equals 6x plus 10, I get f of x equals 6x plus 10. Same deal. And now instead of just substituting in a negative 3 wherever x is, which we've already done this year, I could rewrite this as f of negative 3, substitute the negative 3 in just like we did when it was y equals, and get an answer. And what I'm looking for when they ask whether the function is linear or not is basically, is it a straight line with the slope the same between every 2 points on the line? Okay? What I've already told you this year, if you remember, is that if the equation or the function does not have any exponents other than 1, then it's going to be linear. And when I look at this one, I get basically y equals 6x plus 10, linear. If I look at this one, I've got an exponent of 2 right here. So immediately, just by looking at the function, I know it's not going to be linear. Okay, let's see how we can wrap this up. We're going to wrap it up by giving you 4 practice problems, which we will go over at the beginning of class tomorrow. And you can see what you've got to do here. Use the vertical line test, which I just explained. Graph the equation. Okay, so that means because this is linear, and you should be able to tell me in class why that's linear tomorrow, I can find any 2 points that are on that line. So in other words, make up anything you want for the value of x, plug it in and get a y coordinate and graph those 2 points. And you'll get a straight line. And now we're down here telling whether this function is linear and plugging in x minus 1. So that's that. We'll see you in class tomorrow. Make sure you get these practice problems done and have a good night.